at is a ring in XY symmetry. Now the boundary conditions that we apply will depend on whether we cool in zero magnetic field or finite magnetic field. As I'll illustrate here. In this particular case, we have a ring in XY symmetry, and the magnetic field is increased inside of the ring for a field cool boundary condition where we have normal B is equal to 0 on the superconductor. In this case, we have 0 field cool boundary condition, we have 0 vector potential specified on the superconductor, and flux is expelled from the opening. In this case, this is a flux focuser, and in this case, we have essentially a magnetic shield where we're screening the field from within the superconductor here. So let's look at this problem. Let me first close these windows. So if we look at the model file here, it's very similar to the model file that we had previously. Where we have XY symmetry. Once again, this is the air region. The superconductor now is a finite two strips where I've essentially removed the central region here, so we have essentially a long superconducting ring. And once again, to establish a uniform magnetic field, I've assigned 0 tangential field to the top and bottom edges of the superconductor, and opposite values of magnetic vector potential to the left and the right edges of the superconductor. Now I'll go ahead and refresh the solution here. And you can see that the flux lines are slightly increased inside of the superconducting ring. I can look at a color map of the field density, the flux density. And you can see a slight increase in magnetic field in the central region here. So if I look at my field values, it's roughly 2.3 Tesla here, where it's closer to 2 Tesla far away from the superconducting ring. So once again, we're applying the 0 normal field boundary condition. Now, if I want to make this a 0 field cooled ring, that is cooled in 0 magnetic field, where the magnetic field is switched on after the superconducting state is established, I assign 0 vector potential. So let's go ahead and look at the solution here. Okay, as you can see that the flux lines are expelled by the superconducting ring. And if I look at a color map of the flux density, we can see we have a region of screening here in the central region. Once again, the field is enhanced at the edges, and I can look at my tool here, and I can see I have roughly a order of magnitude screening of the field in this region. This is roughly 2 Tesla outside of the ring, and roughly half a Tesla here. So not quite an order of magnitude. Now this of screening will change for different aspect ratios of the ring For example, smaller inner diameter of the ring will give us a larger screening of magnetic field here. Okay.